I'm Rhett Jesse, and today we're going to talk about the Metrix digital proximity system. Today we have a 5-meter Metrix system. We have a 1-meter probe and a 4-meter extension cable going to our MX2034 transmitter. I'm going to change the gap with this 4140 target. I'm going to go in 10 mil increments, and we're going to record voltages. And we're going to see the linearity of the system. We will then change out the cable and go to a 9-meter system, and then we'll change the configuration within the DPS to a 9-meter system. And then we'll see if that's linear. And that's really our test for today, and that's what we're going to do right now. So to do that, I'm going to go ahead and connect the DPS system to the computer, and you do that with the USB connection that's on the bottom. Now this is usually covered by a DIN rail mounting inside your cabinet. So if you need to do this in the field, you remove that DIN rail mounting, you remove the 3 screws that we have, and then you can get access to that USB connection. So we have a special plate on it right now, and we're going to connect through that plate. But in the field, you just take this off, you connect, you make your changes, and then you put the DIN rail mechanism back on. All right, so I'm going to go ahead and connect to it. And you want to press that USB in there firmly. And then we'll go ahead and start the software. Now the software will actually read what's on the DPS unit. So on the MX2034, it'll bring in its transmitter configuration, which we can change, but whatever's built from the factory, that's what it comes in on. So we can see here that it's an MX2034, its position, it's a MX8030 probe tip, 4140 steel, 5-meter system, and it's presently on 10 to 90 mils. So what we want to do is we're going to keep this configuration, and let's just see if it's linear. Well, to do that, we use the tuning and verification tab. You just click on that, and we can start recording voltages. And this is a system right out of the box. It should be well within the API standards, 190 to 210 millivolts per mil. And with that, we should be able to see that everything is within specification. So the first thing we're going to do is go ahead and move our micrometer. Well, we'll move it 10 mils and we'll take data. And then we say get on the software. It comes up with this warning each time, and the warning basically says, have you moved the micrometer to the right position before you hit get, or before you go to the next step. So I don't need to see that warning anymore, so I'm going to go ahead and say, do not show me the warning. All right, and I'll say yes. And now it will fill in with the voltage that it sees at 10 mils. And at 0.91 volts, that's good. We'd like it to be right at near close to 1, between 0.5 and 1.5. That's typical of proximity systems. And we have 0.91, so that's good. So we're going to move in 10 mil increments. With a slope of 200 millivolts per mil, we're going to go from 0.91, we should go to 2.91, or close to that, within 5% of that number. So as long as I'm doing that, that will be in specification. And we'll see that with the incremental scale factor here on the plot. So let's go ahead and go to 20, and then we'll just do this in 10 mil increments until we get all the data. On this last point, which is 100 mils, it's actually not required by the specification, API 670. So, but we include it because we can. What you see is that all the points are between 190 and 210 millivolts per mil, so it's well within specification, and I don't need to perform a custom calibration. We can just live with it, and we can create a report. And I'll show you a report when we do the 9-meter system. But what I'd like to do now is, since we know this is linear and it's well within the specification, and our deviation from straight line is between 1 and -1, that's what we wanted. Everything is within It's what we wanted. Now what's great is we're going to go ahead and change this from a 5-meter system to a 9-meter system. Then we'll change the configuration and run it again. And that's with using the same digital proximity system unit, the MX2034. We can do this with the driver as well, the MX2033. So you can do this with either the driver or our transmitter. All right. So let's just go ahead and make out that cable change. We'll go ahead and do that. All right, we have our 9-meter system connected, and what we'll do is we'll go back to the home page and we'll do a reconfiguration. So we can see it's still set up for a 5-meter system. What we're going to do is we're going to change the configuration of the DPS unit. So we'll change the configuration, go down to system length here, and what's nice about the digital proximity system, we can actually change lengths for an MX8030 or MX2030 probe in 1-meter increments. What that means is you could have a cable length other than 9, you could have like 7.6, and the system would still work. So this shows you the flexibility of the system. Right now we're going to go ahead and change it to a 9-meter system, and we will send that configuration over. We'll keep it at 10 to 90 mils on the output, and we'll send that configuration, and it will update. And as it updates, it will basically put in a new calibration curve for what needs to happen for a 9-meter system versus a 5-meter system. Say OK. And now you can see that we have a 9-meter system length in the home screen. And we'll go and do that tuning and verification step again. Now in this case, since I changed the system from what was in the factory, I'm going to do this tuning step. So I'm going to basically open the probe gap to where I have no interference with the 4140 target, and I'm going to basically get a data point. So I say offset. And what that does is it really sets the top end of the calibration curve. I'll say yes. And it takes a few seconds to do that, and it will come up and tell me when it's done. And then I'll move the micrometer to 10 mils, and we'll get the 1-volt check, and that will really set our linearity for the system. And that's what's nice about the system is you can make custom changes, and you can get pretty close with just the 2-point calibration, and then we'll do the verification. If it's not perfect, we'll do a custom calibration. Okay, so I'm at 0. I'm going to go ahead and go to 10 mils, and then I'll do the 1-volt check. I'll say yes, and then output will become 1 volt. Okay, we know we get these warnings. I'm going to go ahead and say, do not show me the message again. And it will fill in, and we should start close to 1, and then we'll do 10 mil increments and demonstrate linearity. Okay, we've just adjusted for 1 volt, and now you can see it's very close to 1 volt, 0.999, which is very close. And what we'll do is we'll adjust every 10 mils and to check for linearity. All right, this is our last point, and we'll see if it's in specification. Hopefully it will be. And we see that all the points are between 190 and 210 millivolts per mil, so they're within spec, so we don't have to run a custom calibration. We could run a custom cal, and we could see that we might be able to improve it, get those points that were close to the boundary, right on 200 millivolts per mil, but we really don't have to. This is actually very straight, and you can see that in the graphical line, very straight line. That's what we want, nice straight slope. And we can take this information that we have with this 9-meter system and create a report. So we're satisfied with it. We don't have to perform a custom calibration. We're going to go ahead and generate a report. And to do that, it asks you some information, and this would be typical information you'd put in at your plant. So I'll just say I'm in Houston. And the machine is, I'll just use a compressor. And we can say the tag, we'll just call it bearing 1, and we'll call it X. And we can fill in the probe part number, the serial number, the extension cable serial number, and those things. We can also put some notes on, and that would come out on the report when we basically print this report to Excel and you have access to the data. So I'll go ahead and put who this is. Calibration check was done by me. I'll put my name in, and then I'll say OK. And then it will generate a report in Excel. I'm going to go ahead and put it on my desktop. And I'll go ahead and put in Houston 9-meter test. I'll save that. Say OK. And then what I can do is I can go look at that on my desktop. For the Houston 9-meter test, I found it. I can go ahead and bring up that data. And you can look at the report. The nice thing about this report, deviation from straight line, a little bit high here, so maybe a custom cal would have been in order. If we take a look at the data I put in, it's here. You can put notes in. And this is still, you can still type into this report if I needed to. I can amend this report here. So it gives you a lot of flexibility. Also, the logo you can change out. You can put your own logo in. You can put your address information down at the bottom. And you can also stack these reports. So let's say if you did several of the points on the machine train, you could put all the points having to do with the machine train all into the same report. So it makes it pretty convenient when you're taking probe data. During this demonstration, we showed that the 5-meter system was linear and also the 9-meter system was linear with the same digital proximity system. All we did is change the configuration. This gives you a lot of flexibility in the field, and it's something that our customers have been looking for a long time. Thank you very much.